Thank you. So I always like being one of the last speakers to the conference because you know when whoever comes is really interested in your talk. So it's great seeing so many faces here right now. I'm Károly. I'm an independent Swift developer. I'm not working for anyone. I quit my job 2 years ago to just play around in Swift in a little bit. So I'm doing little experiments on GitHub mostly with open source frameworks. I'm trying to learn the language as it evolves and trying to be involved in its development. One of the things I really like is this concept of reactive programming. Especially in UI development, we have a lot of state to manage. You know, we have to update our UI based on user interactions, and the classical way of doing so in our object-oriented UI frameworks was kind of getting a little bit painful by now, right? So there was this paper 20 years ago by Connell Elliott and Paul Haddock. It was called the Functional Reactive Animations. And this was the paper that introduced functional reactive programming to the world. And this is a quite famous piece of article. We are still studying it and trying to understand it, or at least I am. I'm slowly starting to get in grips of what Connell Elliott is all about. He's still at this. He's still producing articles and researching how to do efficient interactivity in a purely functional environment. Now, Swift is not a purely functional language. It is an imperative language with some functional elements. So we cannot just took Connell Elliott's work and apply it to Swift. We have to come up with our own solutions, some sort of implementations for it. There are two major ways to do it right now. We have two major frameworks for doing reactive development in Swift today. Well, not really in Swift, on iOS today. One of them is React Native. Everybody loves this framework. It's a JavaScript-based thing for creating UIs in a purely functional, really descriptive way. And the other way is encapsulated by this ReactiveX framework, which is really a family of frameworks for different languages. It has an implementation for Swift called RX Swift, but if you know Reactive Cocoa, that's pretty much the same thing. Okay, so we have two very different frameworks for they try to do quite similar things, and they are all trying to implement functional reactive programming in this legacy environment that we have on iOS. Okay, so I'm not going to describe these frameworks. They are both extremely detailed and complicated, but to save time, I will just concentrate on their core features. Okay, so I'm going to oversimplify things. I'm going to discard everything but their primary mission. React and React Native is all about mapping the UI or describing our UI as a function of our state, as a pure function with no side effects. So React is all about writing a render function that we can take and give the current snapshot of our model state to it to get a complete description of our intended UI state. Okay, and this framework does all the rest of trying to come up with an efficient way to display this state on the screen. All right, ReactiveX or RX is about something completely different. It is not really a UI framework, but an event handling framework. Okay, so it makes it easy to process event sources, to transform them into other event sources and other kinds of data structures. All right, so really, ReactiveX is all about trying to find a good way to describe what should happen, what should be changed on the UI if something changes inside our model. Okay, so these are two quite different things. The model of these two frameworks is completely different. They aren't really compatible with each other. But if you think about it, in conventional UI development, you are doing both things at the same time, right? You are writing a lot of imperative code to do it, but you are always at some point you need to construct the view the initial view that you display, and then you have to somehow describe how to apply incremental updates to it to keep in sync with your changes in your model. All right? So we have two frameworks for doing these separate but interrelated things that we have been doing for decades. All right. To reformulate these things a little bit, I think React emphasizes the pull model, where whenever you want the latest state of the UI, you just run this render function and you get it. While Rx is more about a push model. Okay, it broadcasts changes that you can transform to get incremental updates that you can apply on your UI state. Right? But these are two different mappings. All right? The frameworks provide really nice transformations in order for you to build these mappings. But wouldn't it be nice if you could just do a single mapping and to express both halves of this system? Well, yes, it would be. And in fact, the original Connell-Elliott paper described one such construct that lets us do this exact thing. And that construct is called a behavior in functional reactive programming. A behavior is some sort of item, an entity, that always has a current value. It might change across time. As time goes on, it may have a different value. So whenever it changes, you can subscribe to broadcast notifications with a detailed description of each and every change. All right. So I like to call this construct an observable value. You can always get the latest value out of it. And whenever it changes, you can get notifications about what exactly changed in it. All right. So this is the abstract construction or construct that we will need to operate on. Reactive programming is all about taking this construct and applying various interesting operations on it to get some other similar constructs. So let's get started working in Swift. Let's get right into writing some code. The code I'm going to present here isn't exactly valid Swift syntax all the time, but it is very close to what I have in GlueKit. I just simplified things a little bit to make it easier to understand. So this observable value construct we will represent by this protocol. Now, protocols are a way to define interfaces in Swift. All right, so an observable value should have a current value. So we should create an associated type called value. It can be any sort of type we want, an integer, a string, an array, a set, a dictionary, whatever we have. But then we also need to have a way to describe changes to these values, right? And the way we do that is not by specifying a particular way of describing a change, but having just another associated type for it. All right, so that's our change type. Moving right on to our pool interface, we need to have a property to get the current value out of this construct. All right, so that's what it is, a simple value property with the type value and the getter for it. Finally, we also need to have a way to subscribe to changes on this observable. And the construct I use here, the signal, comes from ReactiveX. It has a similar construct there. It is an object that you can give closures, for example, and whenever somebody sends an event on this signal, that closure will get called with the change that describes the update. All right. So, for example, let's make things a little bit more concrete. If we know nothing else about the value type, we can still create a change description for it. In the simplest case, we might just put a snapshot of the old value and the new value together into a structure, and this works just fine for simple types like integers or booleans or short strings. Right, so this is an example concrete change description that is already quite useful for the simplest cases. Let's create a concrete implementation of this observable value protocol. The construct I'm building here, I like to call it a variable because it holds a value and we will be able to mutate it to whatever value we like to give it. All right. So a variable is an implementation of observable type. In this case, we are using this simple change structure as a change description. We need to create a signal to be able to broadcast updates, and we need to create a value property, which in this case will be a simple stored property of type value. And whenever this gets set, no matter what sets it, this set property observer will get run, and it will send an event down this signal, broadcasting the change description to anyone who is interested in it. Right? That's pretty much it. The only thing we need to do is to add an initializer to set the initial value for this variable, and we are done. We have done something quite useful. Because once we have this variable, we can start using it. You can instantiate it, like here is an integer variable of value 42. We can get the value out of it using the value protocol. We can subscribe to it. In this case, we are using a closure that just prints the change onto the console, so that whenever we set the value, we get a single line on the debugger describing the change. We set it from 42 to 23, so that's exactly what we get back. All right. Obviously, if we set the value, the new value, the value property will reflect that change as well. And if we get bored with these notifications, we can always disconnect the connection between the closure and the variable itself. Now, if we have variables like this, let's say we have two integer variables, you might want to do operations on them. For example, if you have two integer variables, you should probably want to add them together at some point. So we could create a sum operation that takes two of these observable integers and returns another observable integer whose value is the sum of these sources. All right, here's the code for it. It's not really simple to write it. It's a lot of code, a lot of syntax, especially all these where clauses. But once you have written this, it works, and you only need to write it once, and you can reuse it over and over again. So what this does is that it initializes the value of the resulting observable sum by just adding together the values of the operands, and then just subscribes to changes to both operands and applies the difference to the result to get the sum updated, to keep it in sync with the input parameters. Okay, so if we have two observable integers, we can create this observable sum construct by this syntax, but this isn't really what you want to do if you want to add two numbers together. So instead, let's create an overload for the plus operator. Everybody loves that. And then from then on, we can just use the plus sign to add these things together. Okay, so we take two observable integers, p and q, use the plus operator to add them together, but we don't get an integer back, we get an observable integer. All right? So if we have three observable variables or integers like this, a, b, and c, we can add them together, a plus b plus c, to get a single sum, which is an observable integer. If you look at its value, currently it's 2 plus 4 plus 5, that's 11. But if we change one of the variables to a different value, the sum will follow accordingly. All right? So simple, I think. What we are really doing is building a dependency graph so that we know what to update whenever something changes. All right? Interesting. Now we can take this ID and apply it to every single operation we ever use on simple values. For example, if you have two equatable values, you can use the equality operators on it, so we can leave this equality operator to work on observables too. It won't return a Boolean anymore, it will return an observable Boolean, which we can use to construct even more expressions out of it. If you have two comparable values, we can define the observable comparator operators or comparison operators and the observable minimum and maximum function as well. If you have two observable Booleans, we can define the Boolean operators. If we have integers, floating point numbers, what have you. Every operation we do, we can lift to work on observables instead. In general, if we have a unary operation, we can use this map function to lift it to the corresponding observable representation. Okay, so in this case, whatever v is, we use this closure to transform v into a string, and we use this map function that works on an observable to create an observable mapping from v to an observable string. If we have an operation that takes 2 arguments, we can just use this combine operation to lift that 2-argument operator to work on observable values instead. And once again, this returns an observable value, not just the direct value. And we can go on, define the combination operation for 3, 4, 5, whatever number of operands. Okay, so this is a general way to describe the operations on these simple values. We don't have to write a huge class every time we need to do one of these things. All right, this is fine. It's mildly interesting. It's not worth changing at all. But what about observable collections? Okay, so that is what this talk is all about. Well, if you remember, in our original protocol, we left the change type unspecified. So we can choose to have another kind of change depending on what value we are using. If the value is a set, for example, a set of integers or whatever, then we might describe a change inside one of those, one of the set values by just listing what elements we should remove from the original set and what new elements we should add to it to get the new value of the set. All right. If we have an array of elements, we could do kind of the same thing. We could describe the difference between the old array and the new array by, let's say, an array of simple atomic modifications inside. Each modification might be an insertion, a removal, or a replacement operation. Okay. If we are clever enough, we could keep this list of modifications sorted by their indices, and we could keep this description as minimal as feasible as possible. Okay, so we have a set change and an array change type. We can go on and define protocols for an observable set, an observable array, and so on and so on. We could create concrete implementations like we did for variable. We could create a set variable, an array variable, etc. So in this table, we have 3 different flavors of observable values: simple scalars, observable sets, observable arrays. All right, these all have a current value that corresponds to this underlying type, but they also provide really fine-grained incremental changes whenever they get updated. All right, so let's take an observable set, for example. What sort of operations can we do with it? Well, one thing we can do is to take a mapping from the element types to some other type and lift it to work on observable sets. So we will be able to map an observable set to another observable set of some sort of different elements, like in this group. Or we could filter the observable set and get another observable set that is a subset of the original one based on some sort of predicate that we can use. We can convert the observable set into an observable array by giving it some sort of comparator function. Okay, in this case, this is particularly important. The sorting happens automatically and incrementally. So this operation doesn't need to sort the set every time something changes in it. It just has to find the place where it needs to remove or insert a new element into the resulting array. Okay, so this is highly efficient. You cannot really speed it up by trying to do this manually. This is the most optimal way you can do sort a set and keep it sorted as it evolves. One other thing you could do is take an observable set and reduce it to some sort of simple scalar value, like take the observable count of a set or sum its elements together into a sum, and so on and so on. You could take the observable maximum, the observable minimum, and so on. You could do hundreds of different transformations for all sorts of operations. If you have two observable sets, you could just define the observable set operations, right? Union, symmetric difference, subtraction, whatever, what have you. Now, if you have an observable array, we could define the same sort of operations on them: mapping, filtering, reductions. We can even take an array and convert it to a set by just taking the union of every element inside of it. If we have two arrays, we could define the observable concatenation of them so that we can glue two arrays together and still have an observable result. Whew. So that's a lot of operations, and most of these, especially for collection types, need to be individually handcrafted one by one, and it's not always trivial to do so, especially if you want to keep it incrementally updating itself. But it is possible. I've been doing it for a couple of months now, so I have a little library of transformations I can use, and I think it's time for us to maybe do a little demo about it. Okay, so what we will do is we will write a little application for iOS that just lists a bunch of colors in a table view. All right, not very interesting app, but I think the method we are going to use is kind of interesting. All right, so I have prepared a little workspace for us, pre-populated with all the dependencies I need. There we go. I hope, I think you will be able to read this source code at least. The Xcode interface is kind of a mess. So what I will going to do, I will talk you through the process. I will just create a new project, an iOS app from scratch on stage. I never done this before. Probably something will horribly break, but we will see. Okay, I will call it colors because it will display a list of colors. Here we go. We can put it wherever we like. There. All right. I will start by adding my dependencies. GlueKit is the name of the framework that I collected here. It has its own dependencies, a couple of things. Done. All right. Does it compile? It does. So let's see what the single view application template looks like in Xcode. So it created a view controller for us. It doesn't include much. Just a stop for a view did load. We won't need receive memory warning. Okay, that's something to start with. We will write a table view controller, so it makes sense to change its type to one. And also, we should just rename it colors view controller. Okay, let's open the storyboard that Xcode generated. Yeah, it's a single view scene. That's boring. No. What we will do instead is that we will drag in a navigation controller. So we will have a navbar, and it already comes with the table view controller populated there. I will just rename the table as to colors. Let's take a look at the prototype cell it did for us. It looks okay. I think we will get away with just the basic style with a title, and maybe we'll set the background to the colors we want. Selecting the table view itself, everything looks in order. Just to make it extra fancy, we will disable the separator lines. That's fine. Taking a look at the root view controller's identity, I think we want to have this set to colors view controller, our custom class, and that might be it. One other thing is that we want to set the navigation controller as our initial view controller. Yep, and now if we run it, hopefully I didn't forget anything. Oh. Obviously, I forgot to set the scheme to this new project. Yeah, if we run it, there is one warning. We will take a look at what it is, but yeah, it starts up and we have an empty table view with a navigation console, with navigation bar. Absolutely fantastic. So what is the warning? The warning is all about, oh, I forgot to set a reuse identifier for our table view cell. So let's do that. Here's the cell. I will just call it color cell. Fine. Okay, so going back to the view controller stuff. So we want to display a list of colors. In order to do that, we have to have some sort of model for the colors we want displayed. Each color will have a name and a UI color instance associated with it. Okay, I have one prepared somewhere. So if I just drag this in, we will have such a color model struct ready-made for us. Okay, a string and a UI color, that's it, nothing fancy. It has to be hashable because I want to put this model into a set that will be our underlying model for the table. So let's do that directly right now. We will import GlueKit, my fancy framework for it, and we can now define our colors set as a set variable of color models. There. All right, so the next step is to create a data source for our table. Okay, that's kind of a boring job, and especially with GlueKit, you don't want to write your data sources by hand. So GlueKit comes with its own ready-made data sources that you can use to populate your various UI kit elements with. So in this case, we are using an array-based table view data source that will take an observable array and takes care of populating a table and updating it as the array itself changes. Okay, let's initialize it. Here we go. Looks kind of difficult, but all it does, it gives the table view to this array-based table view data source so that it can associate itself with it. It specifies the reuse identifier we want to use for the cells we want to create, and it specifies the renderer or the mapping between the model and the cell. The cells are created or dequeued from the table view, so we aren't creating it directly, we got it as an input to disclosure. And what we are doing is we set the background color of the cell to the color instance inside the model. We set the title of the cell to the name of the color, and we are doing something strange here. If the color is really dark, the black title color wouldn't read at all, so I'm taking a look at the brightness of the color, and depending on whether it's dark or light, I set the text color to white or black. In order to do that, I have to have a little extension function somewhere. I think I have it. Yeah, here we go. Wait, where is my... Oh. Yeah. So I have a little extension function prepared already, so I will just pull it into the project, like, wait, is this? Yeah. Pull it into the project, let's say I copy it there. So this extension just gets the red, green, blue components and calculates this fancy random looking expression. It gets back our brightness value that we want. Okay, so switching back to the view controller. Now it compiles, and we can run it if you want, but we haven't specified the mapping between our set and this data source. Okay, so let's do that next. This is the interesting part, because we take the data source and bind it to a particular observable array. Now we have an observable set in these colors, so we can convert it to an array by just sorting it by some sort of comparator function. There are many ways to sort a set. Yeah, colors, thank you. There are many ways to sort a set. In this particular case, we will extract a comparable key out of it. That's kind of right. Okay, and if we run it, we will still have the same state because we haven't actually created any colors yet, but we can verify that at least it's running. And it does, awesome. So let's populate this table view, all right? The way we are going to do that is by creating a little bar button item right in the right corner, let's say with the refresh button. And whenever we tap this button, it will add a single color, a single random color to this list. Okay. So the way we can do that is by, yeah, we have to create an action for this. Let's put it somewhere, let's say here. We want to create an action, refresh action is a good name for it. There, and we have done everything we needed to do with the storyboard. Excellent. So what should this refresh action do? This gets run whenever we tap that button. One thing we could do is just to generate a random color and insert it into this set. Okay, that's simple. How do we generate a random color? Well, I have a list of colors already made. Okay, so here's a huge list of colors from the crayons in the Mac color picker, and here's a function to just pick one at random. All right, so switching it back, we can say that we want to insert a new member into the colors set, and that new member is just a random crayon. Okay, that's all we need to do to manipulate the elements that gets displayed in the table view. Okay, we don't have to notify the table view explicitly. We don't have to do anything special. And it works. It gets incrementally updated. Even the animations work because the table view gets notified of the exact change it needs to do. And there's no diffing going on. So at no point is this framework internally generates two snapshots of the list of items inside the table view, then runs some sort of diffing algorithm in it. No, it knows exactly what happened to the set. The sorting knows exactly where to insert the new element, and the table view gets notified of the exact change that needs to happen. All right, but doing this one by one is kind of a pain, so I will just do a simple loop for this. But now, obviously, we are doing 10 separate modifications, so it will get applied in 10 separate transactions inside the table view. That's not exactly what we want to do. So instead, what I will do is I will create a little transaction on the colors set, so that this bunch of mutations all happen in a single atomic transaction, if you like. Okay. So the table view will get a single update describing every single change that needs to happen to apply to update the UI to correspond to the new model state. All right. Yeah, if all goes well, yes, and it does. We have a nice, huge list of colors. But this is not very pretty. It would be better if we could sort it by color instead, not just by name. So let's add a new button, a new bar button that toggles between various sorting options. All right, so let's quickly switch back to the storyboard, add another bar button. Let's call it sort. And to make it interesting, this time I'm not going to define an action for this. I'm just going to take this sort button and create an outlet for it instead. Okay, so I have created a sort button, tied it up into my UI. There it is. And the question is, how will I handle these button taps without defining an action? And the answer is really simple. I will just take this sort button, and magically it has an action source. Okay, GlueKit defines side loads, kinds of various things on UIKit elements, so that whenever the button is tapped, this event source that's here generates an event with a void value. All right, so what can we do with an event source? One thing we can do with it, well, we can do a lot of things, but one particular thing is that we can count the number of times this event happened. Okay, counted. It returns an observable integer. So we took an event source and converted it into an observable value by counting it. If we know the number of times that button was pressed, and if we want this button to behave as a toggle between sorting by name or sorting by color, we can take this number and map it into a comparator function accordingly. Okay, I have made a comparator function for that. Right? So this is a function that takes an integer and returns another function, a comparator, that compares two color models. Okay? If the number of button presses is even, then we sort by name. If it's odd, we sort by color. Okay? By the hue, saturation, brightness value. All right, so how will we tie this in? Well, we just need to map the observable integer of button presses into this nice comparator function, or using this nice comparator function. And just copy and paste this and say that we want to sort by this expression. Okay, there is no manual handling of actions. There is no mutation, explicit mutation happening anywhere. We just define how this button should interoperate with the data model we are using. Okay. So will it work? I don't know. I hope it will. So we can populate the table view, and if we press sort, whoa, it does work. We can switch back to the original alphabetical order, and we can keep adding new stuff while it's sorted. I think this is pretty cool, isn't it? Ah, thank you. Okay, I think we have time for one more thing to add to this app. It would be nice to be able to filter the list based on the name. If you are looking for your favorite color, maybe that's useful. So let's add the search bar for this. Okay, I will just drag a search bar into this field right there. Let's open up the view controller. Where did my search bar go? Oh, it scrolled away. Okay, create an outlet called search bar. Yeah, it sometimes does it. Let's try again. Ah, finally, okay. All right, so switching back to our sources, now we have the search bar connected. Obviously, we need to have some sort of observable value out of it. That's not very difficult because we have a search bar, so we can take a look at its glue and extract the text field out of it. This is called a computed updatable, whatever that is, but in reality, it's an observable string. Well, actually, it's an observable optional string. Okay. Fine, so this will be the text that the user entered into the search bar. If we have the text, we can create a predicate that matches that text onto with a color model. Okay, so we need to define another function that generates predicate functions for us. Right. Okay, based on a given search pattern, we return a predicate that decides whether or not a particular color model matches that search text. All right, so we can map this thing using this predicate function. And now we have an expression whose result is an observable predicate function. All right, so we can take this observable predicate here and simply drop it into a filter transformation. Okay, that only keeps those elements that match the predicate. Kind of complicated at first, but you can get used to it. And I think this is a much more simple way to program than doing all of these kind of things by heart. So by doing all of this in just, what, 3 minutes, 2 minutes, we have created a little functional little search bar. So if I populate the table, I can find my favorite color, which is, I don't know, aluminum. There. So it all works. and it's still animated, and we can still add more elements or switch to a different sort order, and it all works really well. Awesome. And really the heart of everything is just these 3 lines. We took a whole lot of code, a whole lot of complexity, and hidden it behind this really quite easy to use facade. So we don't have to write the mapping between our table views and our data model anymore. We can just rely on this series of transformations. Okay, is this new? I don't think it is. If you have ever tried Mac development, if you have ever written a Mac app, you have probably come across with a facility called Cocoa Bindings. And Cocoa Bindings has a class called NSArray controller, which kind of does pretty much the same thing as this thing, except it is a little bit more limited. You cannot extend it as much as learning from our accountants and start doing this stuff in our own work as well. All right, so everything is in a cycle. There is nothing new. We just keep rehashing the same old ideas and applying them to new stuff, and hopefully improving upon them and trying to extend them, extend their applicability. So we are all standing on the shoulders of giants, but we are able to see a little farther, maybe sometimes. All right, so this framework is called GlueKit. It's available on GitHub. This is the most experimental framework I have. It is nowhere near 1.0, but I really like to talk about it because it gets me a kick in the ass to start really working on it and finalize it, because this is really the most exciting thing I am working on. And I would really appreciate it if you took a look at it, maybe experiment it with a little. Just don't start using it in production code yet, because the API is kind of messy. All right, thank you. I do have a book. It's currently available in preview form. We are working really hard to finalize it. It will get published in a couple of weeks. If you want to get it in paper form, you will be able to. But in the meanwhile, if you visit this link, you will get access to the ebook version, and when the book finally comes out, you will get upgraded to the final version there as well. Okay? So this book is about Swift collections, implementing them, and with an especially interesting tweak or twist, because I am really interested in how to do fast collections in Swift. So it's full of benchmarking and all kinds of interesting stuff. All right, thank you. For updates, please follow me on GitHub. There's a Y at the end, it is cut off. And or follow me on Twitter, and take a look at my other stuff on GitHub as well. Thank you. I'm not sure if you have time for questions.
Yeah, I guess we can take one question. So
right.
Is there a first person to get to ask the question is the final one. Okay.
Thank you for the great talk. For me, I will try to use it in my project for sure.
Awesome.
Yeah, my question is, what about if we have multiple cells, like classes with the full cell identifiers for the same data source? Do you need to create this like mapping functions, these data sources for each cell identifier, or is there a way to kind of do it in one place?
So this particle data source that I've been using, this only supports a single cell type, but it is really possible to define a mapping from various view model elements to various different custom cell identifiers as well. In GlueKit, the interaction between the UI parts and the abstract algebra parts aren't really well defined yet. So this is the only single data source I have available. But I wrote it last week in about 10 minutes, so it's really easy to add more as we go. There is just so much stuff to add to this project. You can never stop. Yeah.
Okay,
Thank you.
so sorry there is no time for more questions, but thank you once again for an amazing talk. If you want to talk a little bit more, you can grab Károly
Yeah.
during the break or after the conference closings.
Yeah.